Hi class, this is a video on how to write the names for ionic compounds. So last time we learned how to write formulas. If I give you the name, this is going the opposite direction. So if you already have the formula, how do you find the name? To start with, we want to talk about what the names of anions and cations are. So what are the names of our different types of ions? This is just some formatting tips if you choose to take notes just by typing it in. If you'd rather print it or just take your notes down on notebook paper and insert the picture, that's fine with me too. So let's start out. The metal cation, the metal or the cation, is named as follows. We're going to use the periodic table name of the metal. Or if you see NH4 at the beginning of the formula, we'll use the name ammonium. That's the only positive polyatomic ion. In all other cases, you use the name of the metal on the periodic table. We do need to pay attention to whether or not they need a Roman numeral. So metals that do not need Roman numerals are the ones that we already know the charge of, based on where they are on the periodic table. There's only a few of these. It's group 1A and 2A metals. Group 1 and 2 metals, and then there are 3 others. That's silver, zinc, and aluminum. And if you'll remember, silver, zinc, and aluminum are all on a diagonal to each other. Silver at the bottom, then zinc, and then aluminum. Those are the ones that do not need a Roman numeral. Okay, so group 1A, group 2A, silver, zinc, and aluminum. But all other metals need Roman numerals. They do need the Roman numerals. And we'll learn how to determine which Roman numeral it is a little bit later. When we're naming the nonmetal or the anion, we're going to use the periodic table name, the root name, and we're going to end it with "ide" if it is a monatomic ion, or just the name of the polyatomic ion if it's polyatomic. Okay, so "ide" is for one nonmetal. So if you just have one type of nonmetal, we're going to change the name to the "ide" ending. But if it's more than one element that makes up the negative ion, we're going to use the polyatomic ion name. Let's look at how we would write these names for for a compound, not just the ions. For ionic compounds, the first name is the cation name. The second name is the anion name. The cation name is just the metal name, like we said just now. Or it might be ammonium. That's if it's NH4. We will determine and include the Roman numerals when needed. Sometimes it's there, sometimes it's not. Remember, you refer to this part of the table to decide whether or not you need a Roman numeral. Then the anion name is the nonmetal's root name plus "ide" for monatomic ions, if it's just one type of atom, or the name from the chart for polyatomic ions. We have a polyatomic ion chart for that. Now, how do we find the Roman numeral? We're going to spend a little bit of time on this. First of all, remember that the total charges for an ionic compound have to equal 0. They have to add up to equal 0. And I'll show you some tricks on this, but I want to give you the reasoning behind it. The Roman numeral is the charge of one metal atom. One metal ion. Okay, that's what it is. It's the positive charge of one metal ion. Now we always know the negative charge, but we've got to use a little bit of a technique to figure out the positive charge sometimes. Copper is one of those metals. We don't know the charge of it. It's not in group 1 or group 2, and it's not silver, zinc, or aluminum. It's one of those many metals that we don't know the charge of. But we do know the charge of S. If you look at the periodic table, sulfur is in this group, and our negative ions, we can always predict their charge. The last group, remember, doesn't have a charge. That's 0. Then we have -1, -2, -3, -4 for our nonmetals. Sulfur has a -2 charge. Sulfide. It's a -2 charge. So, S has a -2 charge. And I only have one of them. So, that means that the right side of our compound has a -2 charge. Remember that it has to add up to be 0. So what could I add to -2 to make this 0? Hopefully you realize we just need a +2 to add with the -2 in order to make it 0. Those need to add together to equal 0. The last step is you always check to see if we have more than one of the metal ion. Since there's no subscript, we know there's actually only one of them. What we always want to do if there's a different number is divide. We could divide now too and just say 2 divided by 1 is still 2. So the Roman numeral is 2, which if you're writing that as a Roman numeral, that's just 2 I's. So then let's write our name. So this was the Roman numeral part. If we want to write the name, we put the name of the metal, which is copper, 2, and then sulfur, as an anion, we need to change the ending to "ide" because it's monatomic. It's just one atom. So sulfur as a negative ion is sulfide. Copper 2 sulfide is the name. Now let's look at selenium. Find selenium on the periodic table, the next one. It's in the same group, so it's still going to have a -2 charge. So Se has a -2 charge. And we have Cu with a subscript of 2. Okay, this is where it gets a little bit different. I only have one Se, so that means my charge is -2 for the right side. Overall, 1 times -2 is -2. So what would the charge on the left side have to be to make it 0? Well, it would have to be +2. Now, I need to make sure that I evenly distribute that charge, and the way we do that is we divide. So whatever this number is, whatever that positive number is, we need to divide it by the subscript. So +2 divided by 2 is +1, and that is the number I'm looking for, +1. It's the charge of each copper ion. So our Roman numeral equals 1, and if we write that as a Roman numeral, it's just I. So this is copper 1, and Se is selenium, selenium, but I'm going to change the ending to ide, selenide. See if we can do another couple of these. FeCO3, you notice we've got more than 2 elements here. So this has to be a polyatomic ion, CO3. This is when we would look at our polyatomic ion list, which is linked right up here. You could click on that link and it'll take you to it. I've already got it open right here. And the ion that I'm looking for is CO3, I believe, which is right here. That's carbonate. CO3 with a -2 charge. So CO3 in parentheses has a -2 charge. Fe, that's what I want to know the charge of. Well, if I want to balance that out, I only have one CO3. The whole thing has a -2 charge. Then Fe has to have a +2 charge. If it was a different subscript, we'd have to divide. Since it's 1, 2 divided by 1 is still 2. So our Roman numeral is going to be 2, which is I. So this is iron 2, and then CO3 was called carbonate. That's the name for it. You see highlighted in blue. CO3 is called carbonate. Iron 2 carbonate. And then we have Fe2O3. Again, we don't really know the charge of Fe, and we've got 2 of them. And I have O3. Need to pay attention to how this works. Okay, I'm going to find oxygen, find O on the periodic table. It's right here. So that's a -2 charge. Each oxide has a -2 charge. But you see that I've got 3 of them. So I have to multiply. 3 times -2 is -6. That means the other side, if I want to make this 0, if I want to add something to -6 to make 0, I have to put +6. Now I want to know what's the charge of each Fe. Well, if they add up to be +6, and I have 2 of them, I need to divide. 6 divided by 2 gives me 3. So the charge of each Fe is +3, and that's the number I'm looking for. My Roman numeral is going to be 3, which is written like that. So I have iron 3, and oxygen is just a monatomic ion, so the ending needs to end in IDE, so it's oxide. Iron 3 oxide. The Roman numeral is the charge of the metal ion. Okay, let's look at a few more of these. First, with these we need to decide whether or not we need a Roman numeral. So let's go back to how we know. If it's in group 1 or 2, we don't need a Roman numeral. If it's silver, zinc, or aluminum, we don't need a Roman numeral. But all other metals we need Roman numerals for. So we just look at the first element in each of these and decide whether we need a Roman numeral or not. If it's a metal that is not in group 1 or 2, or silver or zinc or aluminum, then we need a Roman numeral. Okay, but Na, let's find Na. Na is in group 1. Don't need a Roman numeral for group 1 because I already know its charge. So I would say, I'm going to put it in there for no, I don't need a Roman numeral. Ag. Ag is right here. Okay, Ag, Zn, and Al, those are the 3 that I know. So Ag, I don't need a Roman numeral for it. Li. It's right there in group 1. Don't need a Roman numeral for that. And then we have Al. That's one of those 3 that we memorize. We don't need a Roman numeral for that. NH4 is not even a metal, it's a polyatomic ion, so no, I don't need a Roman numeral for that. Be, beryllium, let's find that. Right there. Group 2. Group 1 and 2 I don't need Roman numerals for. So no need for a Roman numeral. Then I get to copper. All right, Cu is right there. Okay. It's not group 1, it's not group 2. It's not silver, zinc, or aluminum. It's right close to those, but it's not one of those three. So yes, copper needs a Roman numeral. So I'm going to put yes for copper. And then I have chromium, Cr. Let's find Cr. Right there. Okay. It's in the D block. It's not one of them that I know the charge of. So yes, I need a Roman numeral for that one. And then SnO2. So Sn, let's see, it's way over here. Okay. It is a metal because it's to the left of the staircase by just a little bit. It's not in group 1 or group 2, and it's not silver, zinc, or aluminum, so that means yes, I do need a Roman numeral for that. Alright, so there are actually only 3 that I need a Roman numeral for. I can put an X through here. I don't need to do any of that work for those. So if you determine beforehand you don't need a Roman numeral, skip past that work. You don't have to do it. So these at the top are going to be pretty easy to name. All I have to do is find the metal name and then come up with the anion name. So the metal name for this one, Na, is just the name of Na. And if you find that on the periodic table, the name of Na is sodium. And then if you find Cl, that's chlorine. But remember, in a compound, in an ionic compound, the negative ion ends in "ide." So I need to change chlorine to its IDE name. So instead of calling it chlorine, we call it chloride. Okay, I have Ag, which is silver. And then we have NO3. Okay, that's a group of atoms. It's not just one atom. It's a grouping. So that looks like a polyatomic ion. I need to check the chart, not the periodic table, but this chart over here. Again, that was NO3, I believe. NO3 with a -1 charge is nitrate. NO3 is nitrate. So we would call this silver nitrate. We don't even have to change the ending of polyatomic ions. Okay, S, that's just one atom. So S is sulfur. Remember, we need to change the ending to ide. So it's going to be sulfide. That's our second name. And the first name, Li, is lithium. Okay, the next one, the first name is just the metal name. Al is aluminum. And then NO2, pay attention to the difference here. This is NO2, this is NO3. They're close to the same, but they're not the same. So NO2, even though that 3 is on the outside, we're just looking at what's inside the parentheses. NO2 is nitrite. Similar name, but it's different. Nitrite. Aluminum. Nitrite. Okay, NH4Cl. Don't forget, NH4 is our polyatomic ion, our positive polyatomic ion, which is called ammonium. NH4 is ammonium. And then we have this Cl, which is chlorine. We need to call that by its IDE name, chloride. Be3P2. Be is beryllium. Let me make sure I'm spelling that right. So we'll find it, Beryllium, beryllium, and then phosphorus. We changed the name of phosphorus, take the ending of it off, so instead of being phosphorus, we're going to call it phosphide. All right, and then I have Cu, that's copper. I'm going to put some parentheses there because I see I do need a Roman numeral. But the last name for P, it's going to be phosphide again. Now let's do the work to find the Roman numeral. So I have Cu with a Cu with a subscript of 3, P2. Let's go through kind of the quick memorization way of doing this. I've showed you how to think through it, but there's a quick memorization method, and it's just multiply, divide. If you just remember multiply, divide, that's pretty well it, okay? And what I mean is we're going to multiply the subscript times the charge, and then whatever the answer is, we're going to divide. So let's find phosphorus on the periodic table. It's right here. So what would its charge be? Well, this is 0, then -1, -2, -3. Phosphorus is in the same column, so that's going to be -3. So it has a -3 charge. I'm going to ignore the minus, but I'm just going to multiply 2 times 3 equals 6. Okay? By the way, that's going to be the overall charge on this side, +6. Then what I need to do is divide. 6 divided by the subscript, 3, equals 2. And that's what my Roman numeral needs to be, a Roman numeral of 2. So if you just need a memorization way to do this, you multiply the subscript times the charge, and then you divide by the other subscript. Let's do the next one. Cr is chromium. I do need a Roman numeral. And SO4, let's find it. SO4 is sulfate. Pay attention, SO3 looks the same, but it's sulfite. SO4 is sulfate. It's a good thing we don't have to memorize them, right? So you don't have to memorize these yet, not this year, but you do want to be familiar with the fact that there are some that look very similar. Sulfate. So SO4 is sulfate. And we saw that it had a -2 charge. So each SO4 has a -2 charge. You see here that I have 3 of those, and I have 2 CRs. So the way I figure this out is I multiply and then divide. 3 times -2 gives me -6. That means chromium has to be +6. The positive side has to be +6. And then I need to divide by however many chromium ions I have. I have 2 of them, so 6 divided by 2 is 3. Okay, so we multiply. 3 times 2 equals 6. 6 divided by 2 equals 3. Our Roman numeral is 3. And then SnO2. Sn, if you find it on the periodic table, I guess I should be giving you guys the practice looking at that. Sorry, wrong tab. Sn is right here. That is tin, T-I-N, tin. And then O we know is oxide, and we know we need a Roman numeral. It's oxygen, which ends in "ide" because it's a negative ion, a negative monatomic ion. So tin something oxide. Let's figure out what that Roman numeral would be. Sn, I only have 1 of them. O, I've got 2 of those. If we look for oxygen on the periodic table, we will find that it is here. So it has a -2 charge for each of them. So 2 times -2 is -4. That means this has to be +4. +4 divided by 1 is still +4. So that means I need to have a Roman numeral of 4. That's IV. That's it. You should be able to write formulas and names for ionic compounds at this point. And work on that worksheet. Let us know if you have questions.